Since the birth of mankind on the planet of Earth, all civilizations has used rotation to build their renaissance and to leave their lasting mark in history, making the life of humans and nations easier.
The Ferris wheel is a giant wheel and demonstrates a particular type of motion called rotational motion. It rotates around a fixed axis in a circular motion. In rotational motion, the axle at the center of a wheel remains stationary. The wheel or the object never actually changes its position. We can take a wheel and mark a point O on the rim of the wheel as the reference orientation. This is the point from which the wheel changes its angular position. As the wheel rotates, its angular position constantly changes and is relative to the reference orientation. Angular displacement measures how far the wheel is rotated from its reference orientation. This is the angle formed between point P and the reference orientation O.
It offers superior efficacy. The small round brush head and high-frequency movements clean your teeth gently and efficiently and remove more plaque than a regular manual brush. Slight pressure is sufficient. Simply let the brush do all the work. For good tooth and gum.
Rotation describes how an object turns around a point. It's used to describe the movement of geometric shapes. For example, if you tack up only one corner of a rectangular sign, what's going to happen? The sign swings down. It has a rotation around the tack, but geometrically, it's the same shape. Rotation is really common. The triangles that make up spokes on this bike wheel are rotating around the center axle. Mathematicians use rotation to describe shapes on a coordinate plane too. Check out this triangle. In mathematical language, we'd show it like this, which describes the points of the triangle's vertices based on where they're located on the coordinate plane. To rotate an object, you first need to choose the center of rotation. This is the point that you'll rotate the object around. To make it easy, we'll choose point 0, 0, or the origin, on this coordinate plane. When we rotate the shape, we'll choose point 0, 0, or the origin, on this coordinate plane. When we rotate the shape, we need to keep the shape exactly the same distance, or equidistant, from the center of rotation all the way around. If we rotate the triangle 1/4 turn around the point of origin, counterclockwise, keeping the point of rotation exactly the same, then the triangle moves to a different place on the coordinate plane. The triangle shape stays the same, but the triangle has rotated, and the points used to describe the triangle have also changed. To show that a triangle has rotated, we use a little symbol like this. So now we have turned a geometric shape around a point. That's what rotation means. We can use it to move shapes and describe their movement.
Rotation is an isometry, which means the beginning image and the new image are going to be congruent. You need to know three key things when you are performing a rotation. First thing is a point of rotation. Otherwise, you're just going to be rotating in space. Secondly, you need to know an angle of rotation. That tells you exactly how far to rotate. And last, you need a direction, either clockwise or counterclockwise. So to make this a little more specific, I've drawn a little diagram here that shows rotating point A to A prime about point P x degrees counterclockwise. So again, the first thing you need to know is if you have an image or a point, where are you going to rotate it about? Because this distance between your point and where you're rotating needs to be constant or congruent to your new image. Second thing that you need to know is how many degrees. So you're not going to have x, you're going to have a number like 30. So this would be about a 30-degree rotation, and last, the counterclockwise. If I had said clockwise, we would have rotated it not in this direction, but it would have been over here. So I guess I could call this a double prime. So a double prime would have been a clockwise rotation, x degrees about point P. So again, the three key things that you need to know when you're performing rotation: the point that you're rotating it about, how much you're rotating, and in what direction.
Rotations in geometry mean we're going to have the same shape, same size, but the orientation of the shape is going to change. So it's going to look the exact same, except for it's going to look like it's turned or rotated in this case. And in the instructions on your homework and anything that you'll get, you're going to see that it will tell you how many degrees and which direction. So in this case, for number 12, it says 90 degrees clockwise. Okay, and remember, if you're thinking about a clock, in fact, let's go ahead and write one here. Let's give you a clock so you can visualize what we're talking about. Okay, here's our circle of a clock. Okay, let's give it some times. So 12, 3, 6, 9. Okay. So if you're thinking of a clock, okay, to go clockwise, you go this second hand is how many seconds. But if you go the opposite direction, it's what we call counterclockwise. So I'll go ahead and write it in green here. So the green equals clockwise, and then the red arrow means counterclockwise. So those are the two different directions that my geometric shape can rotate. And it will always tell you in the instructions if you're going to move clockwise or counterclockwise. So in this example, it says clockwise. And so 90 degrees clockwise has a formula, if you will, that changes all the points of my shape, and it will help us convert it easily. Now, you could look at this and say, oh, I can rotate it myself and guesstimate where 90 degrees is, but there's a mathematical way to do it. And the mathematical way to do it is by knowing the formula, which is xy changes to y comma negative x. So the original point xy, when we rotate 90 degrees clockwise, the two numbers switch places, y and x. And remember, the negative sign in algebra means that it becomes the opposite. So if x was positive, it now becomes negative. But if x was negative to start with, it actually becomes positive. So let's take a look at our first point here. Point A is negative 3 comma 2. So when we change it, 2 and negative 3 are going to switch places. But notice that the negative 3 now becomes a positive 3. So my new coordinate for A, or in this case A prime, is 2 comma 3. Let's go ahead and do B. So B was 2 comma 5. It switches, and then it becomes 5 comma negative 2. Because the 2 was positive before, but when you switch them, at the 90 degrees clockwise rotation, it becomes negative 2. And so C was 3 comma 1, but it changes the 1 comma negative 3. And so now you label all of your new points. So A prime goes there at 2 comma 3, B prime goes at 5 comma negative 2, and C prime goes at 1 comma negative 3. Connect all the dots, and you can see it's the same shape, same size, but notice how the triangle has rotated 90 degrees clockwise. So that is how you do a 90 degrees clockwise rotation.